Hello, welcome to this Global Mapper webcast for the month of December. I'm Katrina Schweikert, and I'm here with David McKittrick.
Hi, Katrina, and hello everyone. Thanks for joining us for the last in our presentations for the 2015 year. As you'll see, the slide on the screen, the first slide, indicates that we're going to be dealing with some tips and tricks in Global Mapper. Katrina and I were speaking about this just this morning, and we were preparing, and I shared that this is actually one of the more enjoyable subjects we cover. It allows us to delve into some of those tools in Global Mapper that you may not have used, or that you may have used but used in a different way. We're going to introduce some creative applications for some tools you may be familiar with, and hopefully introduce you to a few new tools as well. So let's get right in and we'll take a look at our agenda for the session today. We're going to begin, this is a fairly involved workflow. We're going to begin by talking about developing a geographically referenced workspace library. During a couple of my recent training classes, I've had discussions with individuals about managing workspaces, and I'm assuming that those of you who are using Global Mapper currently will be familiar with what a workspace is. We're going to talk briefly about what that is, just by way of introduction. But being able to manage workspaces in relation to where they belong. And I'm going to set up a very, very simple little workflow that allows you to manage your workspaces in the context of a map. So we'll get into that one as we start our demonstration. We're going to hand over to Katrina. She's going to talk us through the idea of using a vector template. This is a tool you may not be have seen because it's not actually called a template tool. It's called a pad cite tool, and we'll give you a little bit of a history as to why it was given that name, how it came into being, and some of the applications it can be used for in the current context. I'm going to jump in and talk a little bit about edge matching. Again, a function that you may not be aware exists in Global Mapper, but the ability to create abutting polygons that do not overlap and that do not have any gaps between them. We will introduce the idea of developing a Quiver Plot, essentially a visualization of point data representing magnitude and direction variables. And we're going to use some slope data for that, by the way. We will introduce the heat map function, the density map function in Global Mapper. I'm also going to go forward with that idea of using a gridded surface to represent data. I'm going to bring in some non-slope or non-elevation data and use our gridding tool to visualize that. I specifically want to be looking at some meteorological data and how we can use our gridding tool to visualize that data as an example of how the gridding process can be used in a very creative way. We're going to introduce the Voronoi-Thiessen analysis. I'm going to generate a vector diagram, and I'm actually going to follow on using the same data we used in our gridding exercise in this analysis tool. It's a vectorization tool, lets you create polygons essentially from points. Katrina's going to talk a little bit about spatial bookmarking, the idea of being able to put essentially your thumb in that book and scan ahead a few pages and come back to where you left off in a metaphorical sense. We'll talk about being able to tag a location and be able to go back to that location later. We will talk about labeling. Labeling is always a challenging one, not only within Global Mapper, within many applications. And I'm going to give you some recommendations for settings that can be applied to your labels to make them behave a little better, especially when you're adjusting zoom level scales. So we'll develop some labels that actually scale with your map view. Finally, we're going to have Katrina introduce the idea of visualizing data within a Google Maps interface. There's actually a couple of workflows. We'll hopefully have a chance to do both of them, time dependent, but we're going to, first of all, bring up Google Earth and show you how you can visualize your data from Global Mapper in Google Earth, but we'll also go through an export process and take a raster version of whatever data we have displayed in Global Mapper and display that within the Google Maps interface.
So if you have questions throughout this presentation, this is a recorded webinar, so we can't answer live questions, but you can reach us at geohelp@bluemarblegeo.com. You can also check out the Global Mapper user forum, and we'll show links to those things at the end of this presentation. There should also be, if you're watching this on YouTube, there should be a link to our email address in the
yeah, right in the description below this the video window here. Hopefully you'll see that link in there. So again, as Kat mentioned, if you want more information on any of these tools, you can certainly contact us directly. So as you can see, the first bullet managing a geographically referenced workspace library. We're going to introduce this idea of being able to create essentially hyperlinks within a reference map that allows you to load projects or workspaces essentially that are predefined with all of the required data pertaining to a particular job site or a particular project you're working on. So by way of introducing this scenario, this workflow, I'm going to talk first about building a workspace, building workspace in Global Mapper. Very simple process. Those of you who have used Global Mapper before will probably be familiar with the idea of being able to save a workspace with a collection of layers, whatever configuration applies. Now, ultimately, we're going to end up, as the bullets suggested, with a geographically referenced data management tool. And in preparation for this, I've actually created the final product. So a little bit like a cooking show, we have one that we prepared earlier, essentially, and we will see that final product. But by way of preparing for that, I'm going to show you the various steps that are involved. Now, first of those steps is to create workspaces. And we're going to be working with 3 separate workspaces. I'm going to show you the process of creating a workspace first. Off screen, I'm going to drag and drop a couple of files onto the map. I've got some imagery and I've got some point cloud data. This is the standard LiDAR import dialog box, by the way. This is why we're seeing this right now. I'm just going to confirm all of the default settings. Oh, I've filtered my LiDAR. I'm going to turn off my filtering. Let's go to the filtering options right here in the configuration dialog box, and I will enable all of those point cloud points. So this is just an example, perhaps, of a project area. I've got some imagery. I've got some point cloud data. Whatever data, whatever work you do with this file, ultimately, you'll want to save what you do. Rather than having to manually import your files each time you work on this area, saving a workspace is simply a case of hitting the save button, assigning a name, and it will ultimately save that workspace file for you. I actually have already done that, so I'm going to unload this manually loaded file. I'm going to bring in the workspace, which is ultimately going to be exactly the same data in a pre-saved format. And you'll notice at the top of my screen, confirming the name of the workspace right here, site1.gmw. So this represents one of a number of different job sites that I'm working on. What I want to do is create a reference point that reflects this location. In other words, when I create my geographically referenced project management site, I don't want to display the whole data. I simply want to display a point indicating the location of this data. Now, I could do that manually. I could just grab the digitizer, grab my point tool, and drop a point on the map. I'm going to do it another way. I'm actually going to use the digitizer, and I'm going to select all of the points in this point cloud. I'm just going to drag a box around all of them just to introduce another new tool that you may not be familiar with or may not have seen. When I right click after selecting those points, I have the option under Advanced Feature Creation options to create a centroid point at the middle of essentially my point cloud in this case. And if I use that option, I can define the parameters of this point. I can assign it to a particular layer, as with any point. I can assign it a particular feature type. I can give it a name. So I'm going to call this particular point job site 1 or site 1, whatever would pertain to the location that I'm cataloging. Now, this again is a specific reference point. It's a single point that will give me a visual and geographic reference to the workspace itself. The feature type I've actually already created, and it's called job sites, I believe. I'll scroll through my list of feature types, and job site. It's just something I pre-configured with a pretty large point so I can see it more clearly on the map. And ultimately assigning this to a layer, I'm going to create a new layer, and that's going to be my reference layer that's going to contain all of my job sites when I finish this process. Now, one final thing that I want to do here is to add an attribute, a single attribute to this point that I'm creating. And that's actually going to be a link to a file. And the reason for this will become clear when we show you the end result of this process. If I click the add file link, it's going to prompt me to browse, and I actually remembered where I imported the data from. I'm going to point to the workspace itself. You'll see the workspace that's loaded here, site1.gmw. I'm going to use that reference point as a hyperlink to get to this workspace. Site1.gmw is referenced here. We'll click open, and as you'll see, it adds the file path here. If this was a network directory, it would also direct, obviously, to a network location. In my case, it's local to my laptop, so it's going to load that file, as you will see when I click on the point. Now, with that process complete, I'm going to create a new layer name, call it job sites, and we will see that now added to my overlay control center. I'm going to drag this in from off the screen here, and you'll see now I have a new layer called job sites within which there is a single feature. And you'll see it's got a label. Obviously, we'll need to make sure it's meaningful as far as this particular point is concerned. So we have the job site 1 label there. Now, again, I'm going to bring up the final product of this process. This is a single point, obviously pertaining to a single location. I'm going to bring up a workspace which includes 3 different job sites that I've cataloged. So here we have the end result of that process. But essentially what I have are 3 distinct job sites, each of which obviously represents a location where I have data, individual files, and I performed exactly the same process to get to each of these points. Each one was generated based on that centroid. Each one includes a hyperlink to the actual workspace at this location. And obviously, for this to be meaningful, I've given it a geographic context by bringing in a bounding map with the state of Maine. These 3 sites are along the coastline in southern Maine. I am going to be using my feature info tool. As you can see from my toolbar, that has been selected. In order to avoid the possibility of me actually selecting one of the towns instead of the point itself, I'm going to make the base layer unselectable. And that's an option in Global Mapper for any vector layer. I can select that layer, right click, and you'll notice right here it says allow feature selection from that layer. I'm going to disable the selection. Now the visual indication that that actually has happened, you'll see this is now a red layer in my overlay control center. I can no longer select that layer, and I don't need to, because that again just acts as a visual reference. But what I have on screen now is a geographically referenced project management tool. Each of these is a project, each of these is a workspace essentially. If I want to, for instance, look at job site 2, I simply click on that point. It will prompt me what to do with the hyperlink that is encountered. And from this drop down, you can see the options I have. I can actually display the feature information just like we would with any vector feature. If it's an external file, I can ask Windows to open that up for me. In other words, if it's an image or a PDF, it will use the default application and open up the application to display that file. The final option here is the one we're going to use. We're going to open this selected value in Global Mapper. It is a workspace file that is the target of this hyperlink. So we do want to open that in Global Mapper, and we're going to use that for all of our selections until we change the tool. We'll click OK, and because I already have a workspace loaded, I'm being asked to, if I want to unload the data, it's loaded already, and I will say yes. And you'll see I've used that hyperlink to bring up a pre-existing workspace with a couple of different data layers. Again, just some point cloud data with some background imagery. So you can use a single map as an entry point into Global Mapper, identifying an individual point and essentially going to the data that pertains to that point.
So you chose to do that with points, David, but could you also do that with, say, a bounding box of the workspace?
That would be another great way of doing it. Yeah, absolutely.
Or maybe even take those counties and have that zoom to the
absolutely.
Workspace.
Absolutely. If your project extended to the jurisdictional boundary, doesn't have to be a point. Yeah. Any vector feature, line, point, or polygon can be the basis for that hyperlinking process. So yes, absolutely. In fact, with these small little tiles of LiDAR, I crop them down to a small circle. It's much more likely they're going to follow a more irregular area, and if that's the case, generating a bounding box is certainly something that will be recommended. That can be done, by the way, if it was based on point cloud data. Right click and B boxes will generate a bounding box for you. Then apply the hyperlink to that. So that would be a great alternative to the point alternative that I showed. So I'm going to unload the data just to verify based on I'm going to bring up the original workspace again, job sites, and I'll click on site 3 this time. This is down in the Portland area. Again, we're prompted to unload existing data. We say yes, and brought up the files that pertain to that area. So knowing this structure is available, knowing this workflow management tool is available, all of the data you manage that pertains to individual locations can now be managed with a single introductory map. Now, knowing that, we're going to introduce another component that would be valuable specifically in this context. I'm going to unload this data. I'm going to remind you of a function that's available in the introductory screen in Global Mapper, and that's this button to load sample data. If I click this button, it will bring up a map of the world. That's what we've provided for our users as a sample data, for want of a better term, sample data set. That sample data set resides in a folder, and I'm going to show you the location of that folder. I'm going to bring up a Windows Explorer window here. I'm going to go right to my C drive. Apologies while I delve into the innards of my computer. I'm going to go to my program files. I'm going to go to Global Mapper 17, the version we're using, and you'll notice a folder in here called sample data. here's my countries file. This is the file that's triggered every time I click that button. But what if I want to use that reference map that I just created as a default map in Global Mapper? Well, absolutely. Any data that you copy into this folder will be triggered by that button. So I'm going to remove my countries temporarily. I'm going to drag this over to my desktop for the time being. And I want to take the job sites workspace, again from off screen with apologies. I'm going to drag it and make that my sample data. And we'll close this window, unload the original data. And with my fingers crossed, I want to click the Load Sample Data button. And there we have it. So my entry into Global Mapper is a single click, which gives me a visual reference to all of the locations I'm working in, and a single click then to load that workspace and display the data that's relevant to that location. So great tool using some of the functionality available in Global Mapper to help you manage your data in a spatial context. So in this next workflow, we're going to introduce the idea of using a template to essentially create digitized features. A little context before I hand over to Katrina, and she'll actually go through the demonstration. This function that we're about to show you was originally introduced in a parallel product that we had for several years called Global Energy Mapper. Some of you may actually have been users of Global Energy Mapper. Within that application, we developed a pad cite tool specifically for oil and gas applications, essentially allowing you to place an oil well template at a defined location. And it was introduced specifically for that purpose. Now that GEM has been merged essentially with the standard version of Global Mapper, we no longer have a distinct parallel version. The vector templating tool, or pad cite tool as it's still called, is now available to everyone. And there are a lot of different uses for this, as Katrina will show you in just a minute.
Okay, so we've got a workspace here that just has an image of an area here, and in this example case we're just going to place a template of a building. So this would be assuming that you had a building type that you used frequently, and we wanted to place that in this just empty space here. Perhaps it's a new development site. So in order to do this, we want to turn on the digitizer tool. So that's the little guy up there, and I'm going to right click and use this first option to insert pad cite from library.
The pad cite, again, put in context, was the name that was applied to this one. It was specifically intended for oil and gas applications. So we encourage you to think flexibly on how this could be applied.
So first I'm going to drop down a point that's just going to be the center of my site. I can move that later if I need to. So you can see our default ones here are both related to oil and gas wells, but I can add my own template.
So the formats, it might be worthwhile pausing here for a second, the formats that are supported here are basically any vector format that you can import directly into the application can be now used as a template. Commonly used CAD file formats. In this case, it's a shape file, obviously, that Katrina's going to be selecting.
Yeah, so I'm going to bring in a shape file, but yeah, we could use a CAD format. Perhaps we've got, an architectural plan of
that's probably a common application
a site
for this.
Or something like that.
I think the important consideration here before she actually drops this on the map is that although we know that a shape file is a geographic file, so it has a defined location, by adding it to this templating tool, we're disregarding the inherent geographic information. So it's essentially going to be placed where Katrina clicked on the map.
So I'm going to choose that building footprint, and I can also go back and modify that insertion point if I needed to. I'm just going to go with where I clicked before. And you'll see now we've loaded that building footprint. So this might be a store that we want to build here. Now that we've placed it, we can also go ahead and put it into place a little bit better. So first, we might want to move this a little bit. So also with the digitizer tool, I'm going to right click and go down to Move Reshape Features. So this is all my tools for moving around a vector feature. I'm going to go ahead and go to Move Area Feature. And this will just allow me to drag the feature around and place it where I want to place it. There's also a keyboard shortcut for this. So if I hit Alt with the digitizer tool and then select, you can see now I've got that move option enabled. So that's a nice little keyboard shortcut to get to move. So another thing that we might want to do is rotate this feature. So I'm going to go down to the same Move, Reshape, right-click menu. And I've got a Rotate Scale option. So we'll start by just dragging to rotate this. I'm going to choose that option. And so now I've got my rotation tool. I can move this around, orient it the way that I want to. I'm going to show you one more option with rotating. And while I do that, I'm actually going to throw in some, going back to my previous tool that I just used. So if you've never seen this little shortcut menu, this is going to pull up all of the recent tools that I used, and I can go right back to the rotate scale. I could also go right back to the insert pad site. All the other recent tools that we just used are in this shortcut menu. So now I'm going to choose the option to minimize the cut and fill volume. So this is an advanced tool that is going to determine the orientation that will require the least amount of flattening of the site.
Yeah, you may have noticed, and we probably didn't introduce this in a formal way, but there is actually some terrain data underneath the image you're seeing. So as well as aligning this retail store, whatever it happens to be, from a top-down perspective, we want to make sure it integrates best into the terrain. So cut and fill is a more advanced tool, as Katrina mentioned. If you want more information on that, there are other recordings, other webinar and webcast recordings that go into the details of how that works.
So I'm going to use this option, and we'll just let this process. And so it's going to determine the best orientation for this building that would minimize the cutting and filling required.
And ultimately, it'll give you a choice to apply that or not. Yeah, there we go.
So we could take a look at these parameters, make sure that we do want 145-degree orientation from where it currently is. And I'm just going to say yes to that. So that is the optimum orientation based on the terrain for that building around that center point. So
going back to the templating tool again, it's something that you may have encountered, you may have seen when you use that right-click option. Now that you know what it is, I'm going to hit escape so we deselect that first so we can go back and take a look again. Now that you see that, don't consider this just as a pad site tool, but rather as a more universal templating tool. And the building footprint, as you can see, is noted here along with the others. That will always be available. By the way, if you want to remove an object, these are actually stored in your app data folder. Sorry, Katrina, I'm grabbing the controls here. I'm going to drag a Windows Explorer window in from off the screen here. This is where the building footprint that Katrina just added was actually imported into my local folder, app data, local, global map, or pad sites. This is actually a hidden folder. You may need to enable the display of your hidden folders in Windows, but to simply remove that from the list, I take this and delete it. But you can certainly add your own templates, build up your library of frequently used digitized features so you don't have to recreate them every time. Yep, and so that was actually your app data folder, or you can get to that quickly. Let me just show that. So if you go to the Help menu and go to About Global Mapper, this is going to show you the location of that user data folder. So a lot of this custom stuff is stored in that folder. So the next bullet is edge matching adjacent polygons. I often ask the question when I start a training class if folks could find the edge matching component of Global Mapper, and almost without exception everyone fails. There is no document or no menu item to say I want to edge match, I want to match two abutting polygons. But using an existing tool, it is definitely possible to do that. As you will see in just a second, we're going to essentially generate a polygon that abuts not only with a single polygon, but with multiple polygons, matching them together. So edge matching is certainly an option in Global Mapper. So the context that we're going to be applying this process to, as you can see, is a map of the Midwestern states of the US. Conspicuously absent from this map is Katrina, do you know what state is absent and missing here?
Iowa.
Very good. State of Iowa. No disrespect intended, but very often when you're trying to recount states, Iowa or Nebraska are the ones you tend to forget. I don't know why. But we're missing Iowa here. The rest, obviously, we have the surrounding states, but we're missing the outline of Iowa. Now, my objective in this process is to fill in the blank, essentially. I want to draw the state of Iowa, filling in what's missing. If I chose to do this manually, it would be a very, very laborious process because you can see, especially along the western border here with the Missouri River, there are a lot of different intricate shapes in here, and if I wanted to match every vertex, it would take a very long time. Granted, Global Mapper snapping tool would allow me to do that, but it would take a very, very long time to do that. So what I'm going to do instead is a fairly automated process where I am going to insert Iowa into this space by using a existing tool that was not intended for this purpose. And the tool I'm going to use is the tool for cutting a hole in a polygon. Now, in previous presentations, we've introduced this function as a mechanism for generating what we very often refer to as a donut or a bagel, a hole in the middle of a polygon. We're going to use this in an inverse way, in that what we're going to cut is an arbitrary polygon that I'm going to create encompassing the extent of this state, and what we're going to cut with are the surrounding states. Now, the easiest way for me to demonstrate this is actually to show you. So I'm going to use my digitizer first. I'm going to draw the bounds of Iowa without any care and attention. I'm simply going to draw a very large polygon that encompasses the full extent of the state and then some. We've obviously overlapped the surrounding states, and for good reason. You'll see that in just a second. So this is the standard feature info dialog box. First thing I'm going to do is make sure I type the name correctly. Iowa, easiest state to spell. The feature type I'm going to leave as unknown area type. That's fine in this case. I will assign it to the US states layer. So when I actually apply this and generate the polygon, it will be in the correct layer. And with that, we click OK. And looks like we're done. Good enough?
Nope.
Nope, not good enough. So we're going to continue this process by using the surrounding states as cookie cutters to crop out the extent of the state. Now, again, using my digitizer, I'm going to first select South Dakota, and with the control button held down on my keyboard, in turn I'm going to select Minnesota, Wisconsin, Illinois, Missouri, and finally Nebraska. These outlying states are going to be the tools that I'm going to use to cut the extent of Iowa in the middle. So I'm going to use the standard tool under the Crop Combine Split Functions menu, cut selected area from another area. Now again, this is used mostly for generating holes, but used creatively, as you'll see, it allows me to cut the boundary of the state of Iowa. So that's my cutting tool selected. Now I need to choose what to cut from. And I'm going to simply choose the polygon that I just generated simply by clicking at any location. Final question, would I like to mark the area being removed as deleted? Well, usually you will. If you're cutting a hole, you want to delete that. But in this case, I don't. So I'm going to select no. And when I'm complete, you will see that I now have a complete state of Iowa, digitized perfectly, edge matched exactly to the extent of the surrounding states. Every pixel matches. You will see over here is a little sliver. That's likely because there was a little bit of a gap in the original data between South Dakota and Nebraska. If I zoomed in close, you'll see there's a little tiny section of Iowa that was generated based on the same process, but we can ignore that one. For the most part, as you can see, I was able to achieve the objective, which was to edge match a polygon to an existing polygon. You could also do this, by the way, with two abutting polygons as opposed to a number of surrounding polygons. So that was an interesting, flexible use of a tool that I bet you didn't know was in there in Global Mapper. The next bullet, as you'll see, is generating a Quiver Plot. A Quiver Plot is a visualization of point data within which there is a direction and magnitude value. And you can use this for a lot of different applications. If the kind of the most common one that people think of is wind speed and wind direction. If you look at a weather map, very often you'll get some sort of indication that the wind is blowing in a particular direction at a particular velocity, and that is a Quiver Plot. And we're going to generate a Quiver Plot in this next scenario, but derived from slope values.
Okay, so just for a sample data set here, we've got a low resolution elevation model here, and we've got a little bit of a sample area that we're going to work in here, just arbitrarily drawn. So the first thing that we need to do is, with the digitizer tool again, so what I want to do is drop a selection of random points in this area that we can use for the Quiver plot. And there's a few things that I could do. I could do a regular grid of points. I could use some other point data that I had.
You could manually add points as well.
Yep, I could also use the digitizer tool and add my own points. But what I'm going to do is use the function under Advanced Feature Creation Options to create randomly distributed points. So we're going to use this number here of 300 points, and I'm also going to use this option to minimize the distance. So I want to make sure that nothing is right on top of each other. So
this tool, just before you click OK, there's a lot of different interesting applications for this. As the name implies, it does generate completely random points. There's no pattern to the points. And sometimes in order to simulate the distribution of LiDAR points, you can generate points that are random, literally distributed without any pattern, and then ultimately assign a z-value and export those as a LAS file to simulate what a point cloud may look like. So that's another application for this tool.
And also obviously random sampling.
Absolutely, yeah.
Okay, so I've generated some points in my area now. So before I can create the Quiver plot, what I need to do is give it the attributes. So we're going to use slope and slope direction in this case to assign the magnitude and the direction of the Quiver plot. So what I'm going to do is under attribute style functions, I'm going to apply the elevations. So because I have a terrain layer, it's going to, for each point, identify the elevation, and it's also going to calculate the slope and the slope direction as well. So I can use the identify tool here now. Let me just deselect my points. And using the identify tool, you can see now that I've got a slope attribute and a slope direction attribute. So that was calculated based on the elevation data.
And based on the elevation data of the adjacent pixels, that's how it dynamically calculates the relationship of that particular point to those pixels that surround that point. So it's a pretty complex process that's going on.
Okay, so now to display this Quiver plot, I just brought in my overlay control center, and let's apply this to the entire layer here. So this is my layer with all my points in it, and I'm going to go to options. And under point styles, I've got an option to use a Quiver plot. So in this case, I'm going to use direction and magnitude. And so that's rather than the UV vector option. We also have that option.
Yeah, U and V refers to a U is a magnitude along the relative to the x-axis. V is a magnitude relative to the y-axis, and it computes the aggregate magnitude and direction from those two variables. That's a more involved process.
So in this case, my direction is going to be the direction of my slope, so that's the way the arrow is going to be pointing. And my magnitude is going to be the degree of the slope. And so what we've generated here is a Quiver plot that the size of the arrow represents the steepness of the slope, and the direction of the arrow is the direction that the slope is facing.
So the next bullet is talking about heat mapping. Heat mapping essentially allows you to generate a density map. And you note in the bullet here it says other creative uses of the gridding tool. Gridding tool in Global Mapper essentially allows you to generate a gridded raster layer. And it's typically done with elevation. The data that Katrina was working with previously was a gridded surface model. We're going to use that same visualization to visualize different data. Again, first of all, we're going to talk about distribution or density of data, clustering, if you like, and then we're going to apply a gridding process to a value that's not actually an elevation value. And it opens up kind of a lot of possibilities as far as the display of any quantifiable value that's attributed to a point is concerned. So this scenario, obviously, we're going to focus on the United States. I have some point data. I'm actually got the window open. I'm going to drag it in from off the screen here. This is actually a file I was able to download with some weather information. You've got a straight station ID number for this particular weather station, the name of the station. Importantly, with the lat long, we're going to use our text file importing process to import our lat long values. We've got an actual elevation value for each of these stations, and think that's this column right here, actually. And finally, most importantly, as far as data is concerned, we have precipitation values. So this is the raw material that I'm going to use for doing this gridded visualization of data. So the first thing we need to do, obviously, is import the file. I'm going to use the simple method, drag and drop from off screen. We could go through the file menu, import ASCII text file. We'll bypass that and go straight to this opening the generic ASCII text file option. I want to import points only. You'll notice a few options in here. In fact, a couple that we've added. We've added the area only one in a recent build. That was a new one that's in version 17. We've also reorganized some of the options in here. If you've used this in previous builds, you'll notice slightly different now. But in my case, I'm importing my points only. If you recall, when we previewed the file, the first column was the ID number and the second column was the name. I'm going to skip those two as far as the positioning is concerned. I'm going to ask Global Mapper to ignore those two. So I'm going to ask it to skip two fields at the start, the two columns rather, at the start of each line. Also, my first coordinate value was actually my latitude. So I'm going to make sure that selection is made, as you can see right here. This file is a tab delimited file, so I'll change my delimiting character to tab delimited. I do want to include all of those attributes, so we will make sure that selection is made. And you'll notice here that I have the option to treat the third coordinate value as an elevation value, which, if you remember back to the file, actually was the case. After my coordinates, there was an additional value, which was the elevation. However, in this context, I'm really not interested in mapping elevation. I'm more interested in the actual measured rainfall at each location. So I'm going to uncheck that, but we will address that setting in a manual way in just a second. Now, the final selection I have to make is confirmation of the projection, and this is geographic projection, WGS84. We simply click OK, and as you can see, we have a fairly regular array of points now distributed throughout the US, and indeed one over in Canada here. I'm not quite sure why that one made the list, but we've got one that's escaping, I guess, north of the border. If we use the feature info tool and select a point, we see that we have attributes in here. I haven't assigned attribute names, as you can see, but we have attributes indicating the ID number, the name. This is the elevation value, and this is the rainfall total. So the attribute 4 is the one that I'm most interested in. So before I go any further, what I need to do is I need to tell Global Mapper that that fourth attribute is actually a Z value or a Z value. We know it's not an elevation, but we want Global Mapper to believe it is because we want to create a gridded surface based on that value. And the way that we do that, in the Overlay Control Center, we select the layer, choose the options for that layer, and you'll notice an option to get, and you'll notice elevations is in quotes here because it's not technically elevations, but get those quantifiable values from a selected attribute. And in my case, it was attribute 4. So that means that that rainfall total will be considered the Z value in this data. And we click OK. Now we'll get back and visit that in just a second. The bullet, introductory bullet for this section talked about generating a heat map and also using the gridding tool, both of which are variations on the same theme. So the first thing I want to do with this point data set is to generate a density visualization. Now before we do this, I want to constrain the density grid to the extent of the boundary of the US. I'm going to use the digitizer simply to select that boundary. There actually are a couple of outlying islands. I'm not going to worry about those in this case, but we'll just limit the visualization to the extent of the country, the lower 48, continental US, I guess. You shouldn't forget Hawaii and Alaska. And we are now going to generate a density grid. I'm going to right-click on that layer. I'm going to choose density, create a density grid. And this is the option for visualizing the clustering or the point count within a defined search radius area. This is going to analyze the proximity of adjacent points and come up with a clustering variable. And I am, as I said, going to limit it to the extent of my selected area. We'll click OK, and this should not take too long. It's going to generate a visualization. It didn't actually crop the visualization, it cropped the analysis, so I'm still getting those outlying points, as you can see. Now, to clarify this, I want to do a couple of things. I want to first of all turn off the points. What you're seeing here is comparable to a terrain surface, and as such, it incorporates the hillshade texture, which I want to disable for this case. Now we're seeing a much more meaningful visualization without that artificial hillshade. We're seeing now where the highest clustering of these weather stations are located. As you can see, greater New York area, or New York City area, around the Chicago area, looks like around the Dallas area in Texas, Southern California are where the highest concentrations of weather stations are located. This is a heat map. This indicates relative clustering of data. So if we were doing a quick analysis to see where we have coverage, if these were actual weather, if these weather stations, it was important to know that we had weather measurements being determined in specific geographic areas. We can now see perhaps in the state of Nevada, we may need to get some more coverage in there. So that is a density or heat map, and that can be performed on any point data, just simply based on those that clustering variable. Now I'm going to turn off that gridded model that I just created. We'll go ahead and deselect it. I'm going to turn the points on again, because what I'm going to do now is actually manually generate a gridded surface, similar to what we do when we generate an elevation model, where we identify the z-values, which I've already done, and create a height model, if you like, except in this case, the height model is not going to be based on elevation, but it's going to be based on rainfall. So process is the same. Again, I'm going to limit the extent to the extent of the boundary of the country. We'll go to our gridding tool. From the analysis menu, generate an elevation grid for my 3D vector data. And we're not concerned about the boundary polygon. We'll deselect that one as far as gridding is concerned, but we are interested in the weather stations. We click OK. And we determine the parameters. Now, we don't have to make a selection as to the actual elevation value, because we've already done that. We've already told Global Mapper that that fourth attribute column is the z-value. So we can just go with the defaults here. I will limit the gridding to the extent of the polygon, as we did before. Everything else should be fine in here. We click OK. And again, it's going to generate a surface model for us. And once again, to clarify what we're seeing, I'm going to turn off and deselect the boundary polygon. What we're seeing now is a visual representation of rainfall based on the Atlas shader. Now, truthfully, in this context, I'm not sure that the shader pattern actually works that well. So looking at my range, I'm going to create a custom shader very quickly here that more realistically represents this distribution. From my shader dropdown, I'm going to choose Add Custom Shader. I'm going to call it Precipitation. And I'm going to manually create this very quickly by adding a few colors. My first value I want to leave at 0. I'm going to add that as my lower threshold. I'm going to make that a white color. So areas that have absolutely no rainfall will be close to white. I'm going to add another value, approximately 60. I'm obviously just doing this arbitrarily. And I'm going to use a green color, maybe a more muted green color, to represent areas that are in a range of about 60. And the final value, I'm going to make that approximately 120, 130. It doesn't matter if it's exactly at the upper range, it will interpolate. So again, adding a new value, we'll make it approximately 130 in this case. And I'll make that a blue color. Once again, I'll make it a muted blue color. Now, this should give us something that's a little easier to see. You can see the range of colors that are going to be applied from whites through greens to blues. And important to note that these are blended colors. We are interpolating the colors to reflect the actual rainfall values themselves. These are obviously hard values, 0, 60, and 130. But if a value falls between, if one of the cells falls between, it will apply the color that's interpolated from this model that I've created. So when I click OK, you'll now notice that I have now applied that shader pattern. So what was previously just point data with a value is now a gridded surface. We can see along the west coast, up in the Pacific Northwest, as we know, very rainy up there, wet up there. Not so much in the Great Basin area, fairly dry, down to Death Valley and Sonoran Desert down the southern southeast of the U.S. Midwest, getting a little darker again. Appalachian Mountains have got a little bit of more rainfall in there. So you can see we were able to create a visualization of precipitation. I'm not quite sure what's going on in southern Alabama here. Some local anomaly in our data, perhaps. Maybe one of the weather stations misreported their rainfall for this application. But as you can see, very interesting way to visualize our data. Now, this next scenario is actually going to involve a variation on that theme of visualizing essentially rainfall data. We're going to use exactly the same point data, but we're going to generate essentially a vector layer, a vector polygon layer, derived from this Voronoi-Thiessen analysis process. If you haven't seen this before, this is a very interesting point data analysis tool. Essentially takes a point data and creates an area from it, extending out so each individual area abuts each other, defining the extent of influence of each point. So we're going to limit this a little bit. We're going to do it for a smaller area. We're not going to do it for the whole US, but we're again going to use this as a way to visualize some of our rainfall data on the screen. So we're looking at the same point data as that we looked at before. I'm actually going to limit this to one specific state. I have it's hard to see it in the background here, but I have a layer delineating the extent of the US states. And I'm going to choose Texas specifically. Once again, using my digitizer. Oh, let's try that again. Using my digitizer, I'm going to select the extent of Texas. And I'm going to generate a Voronoi-Thiessen diagram that determines for each point the extent or area of influence of each point. Because in the context of what we're looking at here, we're looking at recorded weather criteria, specifically rainfall. We know that's not point specific. We know the rainfall doesn't just fall at a location, and we can make an assumption that for every point, the same rainfall values extend outwards, and we would assume that the rainfall totals would be the same for areas in the immediate hinterland of every point. So the Voronoi-Thiessen diagram creation will allow us to generate a polygon inheriting the attribute values from each individual point. This is a very simple process. Sorry, Katrina.
So that's the closest location. Basically, would get the value of the nearest weather station.
We would make that assumption in the analysis, absolutely. So, yeah. So, very simple process to generate this model. From the analysis menu, I'm going to go to create Voronoi-Thiessen diagram from point features. We obviously have point features loaded. Very simple dialog box. It's generating a new layer. We'll just leave the default layer in there, layer name in there. We are generating polygons. We don't need to generate a boundary because we already have our boundary in place. The one thing I do want to do is limit the extent. So I'm just going to do that based on what's selected, which is the extent of the state of Texas. And when I click OK, it will go through that analysis process. It should not take too long. It's analyzing each point, and specifically analyzing each point in relation to its neighbor. And when the process completes, we will get, hopefully, an array of complete polygons covering the entire state that will include the same rainfall information that we have for each point. And I'll generate a very quick thematic map just to visualize that. Again, not going to take too much care or attention to assign the specific colors, but we'll just generate a very, very, very quick map to show this data when it's complete. So there we have it. Easiest way to visualize this is to turn off the points in this case, and we'll turn off the underlying states layer as well. And you'll see we now have, except for the border areas, you'll see we didn't actually opt to draw a boundary, but you'll see we have the polygons indicating the extent of influence of each point. I'm going to zoom in a little closer so we can see exactly what's going on. As you can see, each point has been used to generate this polygon. Every location within this point has this as the closest weather station, and likewise every location that my cursor is located within this point has this as the closest weather station. So we're going to make an assumption that the weather recorded here pertains to this entire area. And to confirm that, you'll see that the attributes for the larger polygon are the same as they were for the point that was used to create that polygon. In a sense, it's almost like a variation on the buffering process where we take a point and extend it out, but in this it's extended out in an irregular fashion so that there's no overlap. Every polygon abuts itself perfectly. So the final thing here to complete this process, I'm just going to zoom out just a little bit here so we can see more of this state, is to do a visual analysis of this, just to generate a thematic map essentially. This is done again in the Overlay Control Center for the layer I just created. I'm going to go to Options, and I'm going to generate a new map. Now we know again the extent of this map. I'm just going to put in some arbitrary values here. We're going to apply the styling based on what we see in attribute 4. We know that's our rainfall total. I'm going to put a new value starting at 0. We'll make it a solid fill, and I'll make the 0 value be a white color just as a starting point, and everything else here is fine. We'll click OK, and we'll put a value again of 0. And we will interpolate, making sure our colors are interpolated. We'll put another new value, and we'll make this one 50. I think there's a few areas in Texas that have slightly over 50 inches, but that's fine. We'll make our upper threshold 50. We'll color this time. We'll make it a blue color again, and click OK. The value for this, again, we'll make it about 60. And making sure the colors are interpolated, we click OK. With fingers crossed, we should see a distribution of rainfall now based on these polygons going as you would expect. Further from the Gulf towards the west, slightly less rainfall. Interpolated colors going to that upper level down in the Houston, Galveston area, slightly more rainfall. So then we started with some point data with a value, a variable, and using a couple of different methods, one being the gridding process and the other being this association of a point with the corresponding polygon. We're able to generate a couple of ways of visualizing the inherent data. Okay, so the next bullet on our list, as you can see, is spatial bookmarking. Again, this is an example of a function in Global Mapper where you may not see it referred to as this in the menu, but essentially this is what it does, what the function that Katrina is going to show you what it does. It allows you to establish a bookmark, allowing you to very quickly return to a location, return to a tagged location.
Okay, so we've got a map up here of the state of Maine, our home state here. And so working with this data, I might be zoomed in a particular view. Let's just take a look here at this area. So from the view menu, what I could do is choose the option to save the current view. So I'm going to go ahead and do that. And then say I wanted to go back to the full extent of my data, I can use this home button here. And then at a later point, if I wanted to return to my saved view there, I would just go down to this restore last saved view. And you can see the keyboard shortcuts there as well. So another option that we have is to actually name a saved view, and this would allow it to be available in other workspaces potentially as well. So let's zoom into, this is, let's see, roughly the greater Portland area here. So I also have the option in the view menu to name and save the current view. So this is a little more than Portland, but we'll just use that name for now. And you can see that I could make this available throughout any workspace on this machine or only in the current workspace. So now, as I'm working with my data, I have the option to return to or restore the named view. So this is going to give me a list of all of my named views. So thinking also about the job site one that we were looking at earlier, this could be another option. I could zoom into each of my job sites or each study area that I have around a location and quickly just go back to them. So this restore named view actually doesn't have a keyboard shortcut, but this is another option to look at creating our own keyboard shortcuts. So in my favorite menu up here, I could set up a shortcut for that. And to do that, I would just find it here. Let's go down to the R's and restore named view. So I can give that its own keyboard shortcut. So here's my options here. So I could give this an F key. We'll just give it F2. And now if I hit F2 on my keyboard, I get that list again of all of my named views that I can go back to. That'll bring me right back to my greater Portland area.
So that, when you look at the two variations on that theme, and if you use the analogy of a bookmark as it applies to a printed book, the first option that Katrina showed us here, which is the save current view, the keyboard shortcuts, as you can see, are assigned here. This is like temporarily putting your finger in a book, allowing you to go to another location in the book and quickly return to where you left off. That's a temporary bookmark. The second, and probably the more powerful of the two options, is putting a physical bookmark in the book, putting it on your table and walking away and being able to come back to it. So variations on the theme, and with the addition of the keyboard shortcut that Katrina introduced, it certainly does make workflow a lot more straightforward. So we're going to use the same data. We're going to keep the main data up, and we're going to talk a little bit about labeling. It's always a challenge to assign labels that work in every situation. It's something that we're addressing internally in terms of some of our development work that's going on right now. What I want to show you is a kind of multi-step workaround that you can apply if you want more control over how labels are assigned to features on the map. There is no automatic button for this, and I don't think there ever will be. I think any labeling process is inevitably going to require some level of human intervention. So don't expect at any time that you'll have an easy button that will assign labels in a logical way. What I'm going to show you is, again, it's a tool that's available in Global Mapper that you may not associate, I mean, at least the various components of this workflow ultimately with labeling, but assigned or applied collectively, it does give you an opportunity to control your labeling process in a much more manual way. So again, we're looking at the state of Maine once again, and we're going to apply labels to the polygons you see here. By the way, these are town boundaries. This is the extent of the jurisdictional boundaries, the municipal boundaries in the state of Maine. And I believe there are over 400, I believe, in Maine. Many of them are uninhabited, by the way. You're looking further north, and it's a pretty sparsely populated area. But they've designated these individual jurisdictional areas. And let's assume for the purpose of this scenario that I want to label them. Just so you know, by way of background, Global Mapper will automatically look for an attribute within any data that you import called name or called label or variations on that theme. And if it sees that attribute name, it will automatically assign a label based on the attribute that's in that field. In this case, this data originated as a shapefile, and it did not have an associated label. So if I use my feature info tool and I select one of these polygons randomly, I've only got two options here. I've got an attribute called town and an attribute called county. Neither of which Global Mapper recognizes as being a name. Well, we know that the label we want to assign is the option that's in this town field. This is actually a township range value here. It's not an actual town name. I think we have to go a little further south to actually see a name. Here we go. Here's the town of Whitefield. But we're still going to use that variable, that attribute, to assign a label. So we're going to have to first do that manually. Now, I'm going to show you first the current setup on how labeling works. Then I'll transition to showing you the workflow that lets you address some of the inherent issues you're going to encounter with the default behavior. So how do we assign a label? Well, from the Overlay Control Center, we've got one layer loaded. We go to Options, and the first option under the Feature Type Labels Elevation section, we visited this earlier when we talked about assigning an elevation, actually a different type of z value, a different type of quantifiable value. We were in this tab before. Now we're going to look at the labeling options. What we want to do is choose a specific attribute value for a name. We're going to tell Global Mapper which of the attributes are going to be assigned as the label. I'm going to choose the town option right here. I'm going to click OK. I'm going to confirm the settings that it will apply that label, and you'll see the consequence of that process. Global Mapper is doing its best to display labels in a logical way. Now, in all honesty, when we look at this map, it's very meaningless. We can't associate any of the text on the map with a specific feature. Only when we start to zoom do those labels start to apply in a more appropriate geographic context. And that's because the label size is inherently based on a point size that you have set up. And I believe the point size is, I think it's 10-point text by default. But that's something we can control, by the way. We could change the label size. But still, we're going to run into the issue, as you're seeing at this scale, where this extent of the text goes way beyond the extent of the geographic area. And it's very difficult to distinguish what would be a label, what label would be applied to what feature. The other thing to note here as I zoom in and zoom out, you'll notice that there is a natural text decluttering process, and that is also controllable. I'm going to open up the configuration dialog box right now. I'm going to go to my vector display, and there is an option here to always display all labels. I'm going to drag this off to the side and hit apply on this one. Obviously, this is not something we would use normally, but if I do apply that, there is a result in our case. Again, not that useful. We can see that every piece of text, every feature is labeled. Not a good solution for what we're hoping to achieve here. So I want to deselect that option, and we'll go back to the default. So what is the solution to this challenge? Well, let me first take a look at where our labels are assigned. If we zoom in, every label that you're seeing here is positioned by default at the geometric center of the object to which that label has been assigned. Every polygon, most of these are fairly regular shaped polygons, but if I move down to some of the more obscurely shaped polygons, it might be a little more clear what's going on. Each of these text objects is geometrically in the center of the polygon that has been used to generate that. Because of that, I really don't have any control over the precise positioning. And you may encounter situations where you just want to move the label. Here's a good example with Prospect right here. First of all, we've got a couple of instances of that town Prospect. I'd probably want to remove one and move the other one to a more logical location. Unfortunately, with the default labeling process, I do not have that control. So I'm going to show you a solution for that challenge. First thing I'm going to do is to disable labels for this layer. And for this, I'm going to go to Options, and I'm going to say, uncheck the option Display Labels. We have assigned an attribute to be our label, but I'm going to override that and say, and opt not to display labels for this layer. And as you would expect, the labels are now turned off. So we have a blank slate to work with. As I said before, the label is assigned at the geometric centroid of each polygon. What I want to do is actually generate a point at each of those centroid locations. And in order to do this, I'm first going to select all of the objects in the layer. Right-click on the layer in the Overlay Control Center gives me the option to select all of the features. This is an extremely useful function in Global Mapper if you want to isolate the selection to just objects in one layer, or you want to universally select all objects without having to manually drag a box. Now, I know now that every object in this layer is now selected. Second step in this process is to create a point feature at the centroid. Once again, a right-click option in this case with the digitizer. I go to Advanced Feature Creation Options. We've visited this before when Katrina created those random points. This time, we're going to create a single point at the centroid. So we're going to create a new point at the geometric centroid of every selected area. As you can see, that option right here. It will give me a couple of options. First of all, to create a single point if I have grouped areas, and also to move the centroid point if it's outside, which is something I will want to do. There may be occasions when the centroid is actually outside the bounds. If the polygon is shaped like a crescent, the centroid will technically be outside. So we want to move it inside for what we're hoping to do right now. So we'll make sure those two boxes are checked, and we'll click OK. Now a new layer has been created, a new point layer, and you'll notice because of the label settings I applied to the original layer, those label settings are now applied automatically to this point layer as well. I've assigned labels that were generated from the polygons but are now detached from the polygons. They also generated point features. These are unknown area or unknown point features. It's a predetermined feature type. I want to change that. I don't need to see a dot. I don't need to see a symbol. What I'm going to do is change that feature type. I'm simply going to go to the Edit option for all of the selected points. The fact that they're enclosed in that little red box implies they're selected. So I can edit them and change the unknown point feature setting to text. This is a predetermined feature type that's available for all point data. What's going to happen is the actual point is going to be removed. There'll be no symbol, and the text will be placed right on top of where the point is located. You'll see, let's take a look at Corinth here, just to the right of the dialog box. If we look at Corinth while I click OK, you'll notice that jumps right in. And although the red box is still there, that's a box indicating the original location of the point. There is no point in this case. There is no actual point location. So I'm going to hit the escape button to deselect, and I've now been able to create ultimately the same text, the same labels, but they're now disassociated or detached from the original layer. I can turn that layer on, turn it off. I may even want to rename it labels. You'll see it's now in all of these labels are in my auto user created features layer, but I can rename this to be main town labels if necessary. But I'm still going to encounter the same issue, as you'll see. I've been able to at least create a label process where I can individually manage the labels, but I'm still running into this issue where the text is going to be scaled to my screen as opposed to being scaled to the actual size of the polygons. So what I'm going to show you now is a solution where you can assign a text size that remains the same geographically. Now once again, there's a couple of ways we can do this. I'm going to right click on all of the feature, or on the layer first of all, and select all of the features to make them editable again. And then right click I'm going to go to my edit menu. We could also perform the same action at the layer level by choosing the options. It would be the same end result. With this option selected, I'm going to override the default. In this case, I'm going to specify the style, because what I'm interested most specifically is the font information. I'm going to override the font characteristics. I can change the font from Times New Roman to Verdana. I can change whether it's bold. I could change the point size. Right now it's defaulted to 12 point, and we saw the consequence of that when we zoomed in and zoomed out. I'm going to override that setting, going all the way to the bottom of this dialog box, and I'm going to display the labels using a font at a fixed height. In other words, I'm going to use a ground unit measurement to determine my optimal text size. Now, I have done this already. A little trial and error is obviously required before you apply a physical height. But I've done that already. I believe, if my memory serves, about a 1,000 meter tall text size will work. That's about a kilometer. That's exactly a kilometer. 1 kilometer is going to be the physical size of each piece of text, the physical height of each piece of text on this map. And we'll see if this actually works when I click OK. Oh, maybe a little small. Let's bring it up just a little bit. Again, we'll go back to edit, and again, we'll override choosing, and we'll try 2,000 meters. And click OK again. I think it's because I changed to Verdana. Maybe that's why I changed the font characteristics. We'll click OK. That looks a little better. Maybe a little large still. Well, we'll assume that we've got it right. But you'll see the consequence of that process is that my text remains the same size regardless of what my zoom level is. So, for instance, looking at Corinth here, if I zoom in once again, you'll see it remains the same size relative to what it's labeling regardless of my zoom level. Now, the other thing to note here is I have the option to move text around. Because these pieces of text are now independent of the polygons, let me actually make the underlying layer deselectable, just like we had done before. So I can choose the text and not the actual. Let me grab that one. It's probably offset slightly. There we go. That's where that piece of text is. And I can pick this piece of text up, knowing as we did before that if we hold the Alt button down, that creates a move option. I'm going to drag that over so it's a little more logically placed. I now have complete control over the positioning of our text. Once again, we'll choose Lowell here to see where the point is. It's right here. Once again, we will move that text over towards the center a little bit. So we now have control over the labeling position. We can delete labels which we don't want. If they're repeated labels, for instance with Brewer down at the bottom, we could delete those. So that's a tool that you can use to more specifically place your text on the map. The actual text itself, the labels, were derived from the same source that we applied at the start of the scenario where we had Global Mapper automatically apply text, but now based on a couple of steps in this workflow, we now have independent control over those labels. So the final bullet in our tips and tricks list is a visualization tool. A couple of applications for what we're going to show. In fact, a couple of variations on the theme. Essentially being able to view your data from Global Mapper within Google Maps. And we're going to talk about both Google Maps and Google Earth. If for instance, somebody sends you some data and you want to see where that is in the real world, there's a great little tool that's available in Global Mapper to quickly visualize that in a Google Earth framework. Also, Katrina's going to show the process of exporting data and being able to display that within a Google Maps interface.
So we've got a layer here of parcel boundaries, another town in Maine going on the theme here. So we get asked a lot in support about interacting with Google data and, the great imagery and data that they have. And so we do have a couple of options here to take a look at this data in the context of Google. So for example, say I got this file, as David was mentioning, and I didn't really know where it was in the world. From the View menu, one option that I have is to just go directly to view the data in Google Earth. And we've got some action going on off screen here on our second monitor. Let me just bring that into view here. Oh. There we go. And so now we've zoomed into that location in Google Earth. So this is based on the data that I had loaded in my workspace. So another option that I have as well is to select the data in this layer. So I'm just going to right click in my overlay control center and select all the features. We've seen this tool before. And now if I go back to that Zoom to View in Google Earth, it's going to give me the option to include the selected features. And I'm going to say yes, and since I already have that file loaded, I'm going to say yes, I do want to reload it. So now this time I've brought in my data into Google Earth. So it's quickly generated a KML that includes the data, and this is actually interactive. These are vector features here, so I can actually click on them and get my attributes from my shapefile that I had in Global Mapper. So that's one great way to interact with my data, quickly see where I am, and use some of the Google tools.
And we've also some folks have indicated they use this just to verify that the projection parameters they've established are correct. So obviously you can see the data in this case lines up pretty well with what we're seeing in the underlying imagery. So it's a kind of a QA process in a way.
Mm-hmm. Okay, so another option that we have that we might be interested in doing is actually generating our own, I guess, website, really. You could use this to create a web interface that would have the Google tiles in the background. We also have options for some other tiling software as well. So this is from the export menu. And there's an export option for web formats. So I'm going to go ahead and click on that. And you can see we've got a couple of different web formats. I'm going to go ahead and make some Google tiles here. I could also do Bing. Got some other options as well. And you can see I've snapped into the Google projection in the background there. So I've got a lot of settings here that I can choose from, the zoom level that my data is going to show at. I'm just going to stick with the defaults for this.
And if you see before you click out, you'll notice here, and this is kind of a clue to what's going to happen, over to the right side of the window, we can now control, based on what's going to be generated, how this will be displayed. I assume most of you, the users out there, are familiar with the Google Maps interface, where you've got a scale bar, you've got zoom, you've got even street view, that little guy that hovers and drag him onto a street to see what the street view. Those elements can be added to the interface once Katrina finishes generating these tiles. So we can also default to the street map or satellite view, as you're saying.
Yeah, I could change to the satellite imagery view.
And that's just a default. You can change that within the interface when you get there,
Yep, so I have all those options for including the controls. And I'm just going to constrain this. So tiles are actually quite a large set of data that we're going to produce here. You'll see in a minute, as we start to produce these tiles, we're actually going to generate hundreds of images of our data. It's going to take just a minute. So we've got, in this little area here, because of all the zoom levels, we have 798 images that are being generated.
And the reason for that is because as you zoom, the data is essentially being resampled. It's not vector data that's being generated, but it's a raster tile. So if you're looking at the imagery or the data from a high level, you're going to see less tiles. As you zoom in, it will increase the number of tiles.
So I just clicked yes there to open it up in the web browser. So now I've got basically a web interface that's been created that has my data on top of the Google tiles. You can see the levels that I set. So at some point, that's the minimum that I set for zoom level. And also at some point, the maximum will be reached for zooming out. I've got the controls that I chose here. I could also use the street view here. All those options. And so right now, this is just stored locally on my machine. But if you look at the HTML there, it would be very easy to turn this into an actual live website. You just need to change the location of the images to be the location on your server instead of locally.
Yeah, and it might be a good idea. I'm going to go off screen as well here just to show you actually what was generated. I'm going to have to navigate to the file with all the apologies here, but this is actually the outcome of that export process. And the key part here, here's the different zoom level tiles. Katrina had selected 5 zoom levels. Within each of these, by the way, this is where we'll have the individual tiles themselves, the individual images. But the key part of this is the HTML file. So anybody who has any web savvy at all, as Katrina mentioned, can very easily turn this into an out-facing site. Important note, though, what Katrina demonstrated when we viewed the data in Google Earth was that it was interactive. This is not. This is a raster image, essentially. These are originally vector tiles, but they have been rasterized during this process. Well, looks like we're out of time. I think we've run over just a little bit once again. Hopefully, some of the tips and tricks we covered today you'll find useful. Creative uses of Global Mapper, creative uses of perhaps some of the tools that you've been using already, but just using them in many different ways. Hopefully, there was some information here you'll find useful. Thank you for your help today, Katrina.
Thank you. So you'll see on our screen here, we've got some resources if you would like to contact us. geohelp@bluemarblegeo.com is our support email address, and also you can check out the Global Mapper forum.
Yeah, and if you're not currently a Global Mapper user, I'm going to put a link in the description below this video that you can go and download a trial copy. We'll give you a 2-week trial, so you can try some of the things we've done today or visit some of the other webinars you'll see if you subscribe to our YouTube feed. There are several dozen webinars that we've posted that give you information about specific elements of the application.
So we'll see you next month. Thanks for joining us.
Thank you, everyone.